Hi, my name is Hari Balakrishnan. I'm a professor in the Computer Science and Artificial Intelligence Lab and the Department of ECS at MIT. About 20 years ago, together with my colleague Professor Sam Madden, I led a project in the area of mobile sensing called the Cartel Project. In mobile sensing, the idea is to take data from sensors on mobile devices and Internet of Things devices attached to vehicles to understand transportation issues such as efficiency and safety. In 2010, based on the academic success of the Cartel Project, I co-founded a company called Cambridge Mobile Telematics, or CMT, whose mission is to make driving safe and sustainable around the world. The rise in distracted driving has directly led to an increase in road crashes and fatalities. At CMT, one of the observations we made many years ago is that the same smartphones that are causing a lot of these problems could be used as a force for good because they contain a large number of sensors that could be used to automatically measure how people drive. And that's what we built at CMT over the past decade. But not only that, we've also developed an innovative Internet of Things or IoT technology called the Drivewell Tag. These Drivewell Tag devices are small 2-inch by 2-inch devices that attach to the windshield of the vehicle that come with their own sensors, communicate with the phone, allowing us to process data to measure how people drive. We've built and shipped over 30 million of these devices worldwide over the past several years. In 1998, there was a lot of excitement in the community with the possibilities of bringing together computing, wireless communication, and sensing into small form factor. I got interested in how to take this idea of sensing and apply it to assets that were moving, namely cars and vehicles.
When I got to MIT, Hari had been working on the Cricket system, which is an indoor positioning system, and it had a lot in common with the kinds of things that we were building at Berkeley. It was a wirelessly networked sensor system. And so he and I started thinking and talking about how we could collaborate, and we both got very excited about this idea of mobile sensing.
In 2004, this was the advent of the Cartel Project, one of the first projects in the world on mobile sensing, which is a combination of sensors on mobile devices and being able to draw inferences of what was happening. So we did a number of different things within the Cartel Project. Jacob Erickson, one of our postdocs, had this idea that, hey, we built all this stuff. How do we get a lot of data and how do we do something useful with it? He said, let's partner with local Boston taxi companies and put this stuff on their vehicles and go about driving and measuring road surface conditions.
We sort of doubled down on this idea of safety and measuring whether drivers are safe and roads are safe. We identified a number of different commercial markets with some of the big insurance companies who were also coming to realize that you could use sensing as a way to really directly measure whether drivers are safe.
I started reading about insurance companies putting expensive hardware in vehicles to measure people's driving quality, to price insurance correctly and maybe give people discounts for better driving. We built all this technology with mobile sensing from phones as well as inexpensive Internet of Things devices. We could absolutely beat these expensive hardware devices that people were going after. And in 2009, started the company on the backs of a NSF small business grant, an SBIR, that really allowed us to take the technology, license it out of MIT, some software out of MIT, into the company, and that really led us to create CMT. One of the challenges to measuring road safety is collecting large amounts of data, and that comes from sensors on mobile devices. They come from the tags, they come from phones, and increasingly from connected vehicles. And we also process data from video sources. But how do you calibrate these? This is a piece of equipment in our lab where we can take these devices, attach with sensors, put them here, and then rotate these devices or have them accelerate in different configurations and see what the quality is, and then decide how to take that data and put them in a form that's equivalent across different data sources before we put them out in the field. Advanced computing and AI technologies are fundamentally important to draw inferences from sensor data to understand and improve road safety. For example, when a phone is in a vehicle being driven, how do you know if it belongs to the driver or a passenger? Obviously, as a driver, you shouldn't be using your phone while driving, but a passenger can use the phone all they want. So you need to differentiate between these two. So how do you know if you're in a car or some other mode of transport like a bus or a bicycle or a train? And that involves machine learning as well. As a driver that's in a crash, how can you tell the difference in real time using noisy sensor data between a genuine crash for which roadside assistance has to be sent versus somebody hitting the brakes hard and the phone flying off? These are the types of problems that we at CMT have been tackling for the better part of a decade to make our roads and drivers safer around the world. Over the last 10 years, CMT has grown to become the world's largest telematics service providers with over 450 employees. What I've found is that the two biggest attributes that determine success in our field are intellectual curiosity and collaboration. This is a really exciting time to be working in the field of transportation and automotive and road technologies. One example of it is understanding driver risk. Another example is in understanding the inherent risk of vehicles and making vehicles safer, and understanding road risk. The combination of sensor technologies and artificial intelligence is fundamentally changing these fields here. So I couldn't be more excited for the future of how AI impacts road safety. Don't drive distracted, folks.